Okay, so good evening, everyone. This is a special type of invited talk. We incorporated it as part of our class and intro to cloud computing because it's very relevant. I have our guest here. Thank you so much for coming here. His name is Vidya Agarwal. He's a principal architect at Mobile. Oh God. Okay. And I got to attend one of his talk during last year with the Seattle Code Camp 2018. With some of our CE students went there and experienced a weekend type of a lot of talks as well and workshops. Then I met him and I was like, wow, amazing. He's a good explainer about microservices architecture. I was like, I want to bring him in the school. So here it is. After 1 year, we got to pick the schedule, and you can tell more about yourself later. And that's it. Yeah.
Thank you, everyone. It's a pleasure to be here. As Clark has briefly introduced me, the topic today we are going to talk about is microservices architecture. Before we start, I would like to know how many are students here? Are all of you students? Is there anybody who is professional working in industry? Okay, you are. All right, that's good. So the topic here is going to be about microservices architecture, which is a pretty cool thing. How many of you have heard this term before, microservices? All right, very cool. So this is a new buzzword, by the way, in industry. All right, this is the most happening thing today in industry. Now, when we are students in college, university, and wherever you are doing some learning, it is very hard to know what career path will you be pursuing. Like, for example, I spent most of my life in server-side architecture. You know, that's where architects do their job, like server-side programming, Java, C#, .NET, Spring Boot, and all that stuff. What if tomorrow you become a mobile app developer? Think about it, right? You could be a mobile app developer. You want to be a front-end designer. Think about any application running in your phone, even your Google Maps, your Uber. Any application running today in your phone all have some sort of services running behind the scene. Tomorrow, if you want to build your own phone app, where will you get the data from? You need to go and source that data from some server from somewhere, right? So all that data interaction from UI, user interface, which is your client application, to the backend, all these things happen through services. And microservices, one of the aspects, one of the style of building service infrastructure. So this is a little bit more about me. I'm having close to 20 years of experience in industry. I'm working with T-Mobile for past 2 years. Yesterday was my second anniversary with T-Mobile. August 7th, 2017 was when I joined. I'm also a Microsoft MVP, which is a most valuable professional. Microsoft selects approx 4,000 people across the globe every year, and I'm holding this award for past 6 years. There is a website, C# Corner. Many times when you do Google search, you may run to that website without knowing what that website is. But C# Corner is a community website. I'm also MVP over there. I'm also a TOGAF certified architect. I have certified Scrum Master and over a dozen certifications from Microsoft. I have authored 5 books. 3 of those are lined out here on the right-hand side with a black and yellow cover with AFS. And I have done over a dozen technical review. Technical review is when somebody writes and you verifies that everything is right or not. So before we get into microservices architecture, let's discuss first what is before that. Because if microservice is a new term, what was before that? Has anybody heard this term monolith? Okay, no, and yes, both feedback I got. So let's go with the rhythm that what monolith is. Monolith, as the name says, it's a one big bulky code. Think about it, you are writing some functionality. Let's say you are writing one application which will do multiple things for you. Any website, let's say you are building a website which will allow you to sign in, but before you sign in, you need to sign up, right? Then you can sign in, and once you are able to sign in, you can go and look your account, you can update your account, you can change your address, maybe you can order some things like online shopping. Think about any website where you buy clothes from. Think about how many different functionalities they are doing. When you order things, they will take payment from you. Once they take payment, they will ship it to you. All these things are happening. Now all these functionality and the code you are going to write in one big large code base. Code base means whatever programming language you choose, you are writing all that code together in different files, but it's all together. One big bulky thing. And when time comes, you deploy it on the server, people start hitting your endpoint, and then they see the functionality. They go from one page to other page. But all that thing is happening at one place on the server. All that code is deployed once on the server. Now that is what Monolith is. In this definition, I included a couple of technical terms. For example, MVC. MVC is Model View Controller. It's a design pattern in industry, and that is what most of the programming languages support. And if you want to make any service, this is the design pattern which you need to understand. Anybody know about MVC a little bit? Can I see the hands, please? Okay, good. So MVC is Model View Controller. Most of the programming languages support it. Now there is another term called POJO. POJO is plain old Java objects. And then there is another one, POCO, that is plain old C# objects. Now this is a terminology related to MVC pattern. So rather than going with the text and definition there, let's look at the diagram. This is the diagram I built by myself on draw.io. It's an open website, you can draw diagrams there. So I drew it. Now think about it, on top is your application UI, this thing here. That is your application or your user interface. Now that application has some forms in it. It's a UI, it's supposed to deliver some functionality. Think about that functionality is about a customer, as I gave you one example. Any industry you go, you need customer, no matter what you do. Even if you are launching a game, you still need a customer, right? You want to sell it tomorrow, the advanced version. Initially, you will give free. You need customer to use free, and then they will pay you. If you are launching an e-com website, you need customer right away. So customer is a very important thing. From the customer, you want to receive orders. Before you ship the order, you need payment. In order to place the order, you need to have an inventory. And while you are taking payment, shipping orders and all, you need to involve into billing. So these are like 6 basic things for any website or any application you are building around, which has money, customer, and all these things. Customer, right? Payment, order, shipping, billing, inventory. That is where you will see how many items do you have before you ship. If you buy anything online, there is always an inventory check before that order is being confirmed, before they receive even payment from you. They want to make sure this item is available. Many times, if you guys do online shopping, you will notice many times when you go and select it, it's not there. Or many times the size or the color you want, that is dim, like it's grayed out. The reason is that was not in inventory, even though when you apply the filter, it selects, but that thing is grayed out because it was not in inventory. So how did UI figure it out? UI doesn't know by itself. When you are doing filter, you are basically building a query. That query was sent back to the server, and server will make another call to check the inventory and bring data back that for this thing what customer was asking, it's not available, means null response or 0 or whatever. And then based on that, you say, okay, if it is 0, let me gray out that one. If something is available more than 1, let me make that highlighted or bold. So you can click on it and go further, right? So all these things happen here. So that is Monolith. Do you guys understand what I'm talking? Do you have a visual clue what I'm talking? Think about all this functionality, very simple, okay? Forget about MVC, POJO, POCO, all that. Because you guys are students, you don't know too much about it, these industry terms. Think about all this functionality. I hope that makes sense, because we are also customer to so many websites, right? We always buy something, place orders, we have billing and all that. So think about it, all that functionality is being built together and deployed together. So this will be deployed on a server, and you need database. Can you name few databases for me? Any database name you know? MySQL, MongoDB, DynamoDB, Oracle, MariaDB, SQL Server, right? There are so many, CouchDB. There are so many, right? Now, Aurora DB is another one. Amazon just launched, like last year in their Amazon reInvent in Vegas. They announced that Aurora DB is the new one coming. So what happens is you do not need to know all those databases. You need to know only one NoSQL and one relational. If you know these two, and anyone know Oracle, if you know Oracle, you can easily work on SQL Server and vice versa. So do not try to get your hands dirty on everything because that won't add much value, but you should know one NoSQL and one relational for sure. Now, since we were talking about Monolith, let's see what happens here. All this functionality, wherever you need data stored in the system, all that is stored in one relational database. Mostly, all the monoliths are built around relational databases only. That's the only way they can establish relationship between the tables, right? So if you go to my account, let's say you are paying some online bill for something. How do they find you? How can you go and look for your old bills? Many times you are able to find your previous bill, your history. Like if you go to Amazon, for example, you can see your order history for past few months, right? How do you do that? Because that all is stored in some sort of database, in some storage. It's living somewhere, right? So let's go to next slide. Any questions on this so far? I want to keep it interactive for you guys. So feel free to raise your hand, ask me questions if you're not clear about something. Yes, sir.
Yes. You said a monolith, and then you put it in the SOA.
Yes.
Will you explain that?
Yes, good point. So SOA stands for Service-Oriented Architecture. So there is SOA architecture and microservices architecture. So when we talk about SOA, anybody have heard that term SOAP?
Yeah.
What does that mean? What is that? SOAP, S-O-A-P, SOAP stands for Simple Object Access Protocol. If you go to weather.com, there is one more government website from United States called NOAA.org. That's the weather station. They own the satellites and all in United States for weather. Now they will give you, they have exposed APIs. Weather.com also has. Now they expose the APIs, you go consume their API, you give the latitude, latitude, and then you will get the data back about your weather reporting. That data comes back in XML. And that is what SOAP services were based on. Most of the SOAP services and SOA architecture, which was Monolith, is based on SOAP and XML, and that is what was SOA. So Monolith is also known as SOA architecture, means service-oriented architecture.
I think it's the rule from. You just 6%. So while we're reading, can you talk more about what are these plain old Java objects and plain old C# objects?
Yeah, sure.
I've never heard of them.
Sure.
I heard this 15 years ago.
So what happens is, so when we are talking about programming, right? In programming, so I talked about three things, right? MVC. Right? Now, what happens is you have a view. Okay? This is your view. View could be your UI. That's what view is, right? You have UI. In UI, let's say I'm asking for name, age, all right? And I'm asking your address, for example. I'm asking three things in my UI. That is my view. That is what my view is. Now, what happened with this view? The moment a customer is hitting the endpoint, how do you do that? You go to your browser, right? Either it is HTTP or HTTPS, and then you hit your endpoint, and that will open the UI in the browser. Is that right? Are we good on that so far? Yeah. That is what my view is in MVC. This view could be made in Angular. Everybody has heard about Angular, AngularJS, JavaScript, HTML5, CSS, all these cool things. So that is what your view is. That is what client-side code is. Client-side means what front-end developers or front-end designers create that thing, right? Now, that is what view is. when you are hitting this view, what happens is a request goes to the controller. And controller is nothing more than the server-side code where logic lives to go and fetch the data from the database. So let's say this is my database where we have the information or we want to store the information. So from the database, either you write or you read. Make sense? When you are reading, you might think you did not say update and delete. That's of course. So you are reading, you are writing, updating, deleting. Writing, reading, updating, deleting to the database in industry is called as CRUD. Anybody know this term? CRUD?
Yeah.
Create, read, update, delete. We call it CRUD operation. So in industry, all the devs, people to each other, when we work in companies, we talk like that, CRUD operation. So what CRUD operation you are talking? Oh, read. Okay. So now what happened? Call comes here based on what you are asking. Let's say I am doing search. Right? I'm searching something. Then when you do that search and I write here my code 1, 2, 3, 4, when I click on that button here, let's say this is a check mark button, I click on it. From this view, call goes to controller. And what does controller have? Controller is always server side. It could be in C#, it could be in Java, Spring Boot, whatever. It could be SOA or it could be microservice. Now, do not worry about what microservice is. We are going there. Now, in this controller, you will have some sort of code. Public controller, I call it custom. Okay. Inside that, you will have another function, public. I say, for example, string get customer, and inside that, I am asking you integer customer ID, right? And inside here, you have all that code. What that code does? That code is actually having logic in it to go and talk to the database. Yes.
So why they do this, the code search database fetch data to the controller inside of the model?
I'm sorry, I didn't get it. Can you speak louder, please?
Why they put this, fetching data, logic go to the controller instead of putting the model?
So that we are coming to model here.
Okay.
So it's not in the model. The logic is here, but how would it put it? That is in the model.
Oh, okay.
So model is the replication of what you want from the controller. So I'm going step by step.
Okay.
I only explained view, controller. I didn't talk about modeling. Now this controller, I'm explaining what is in here. What is in controller. Now what happens is this controller is going to talk to the model. And model is where your Pojo or Poco is. So model look like this. Public class customer. And inside that you will see things like string name. And you can get it, you can set it. Get and set means you can read it, you can write it. Now another property is whatever fields you have in the database or whatever fields you want to receive, that you will define here. The other one would be int age, right? And same, get, set. Then there is the date of birth or address. So for example, now next is address. So string address, get, set, and you close the class. Now when you are in your controller and you build a query, you will refer these properties from the Pojo or Poco. Pojo is plain old Java objects. That is what Java programmers use. When Microsoft launched .NET, they came up with their own thing because they launched the programming language C#. They started calling it Poco. Plain old C# objects or plain old CLR objects. So this is how model view controller connects with each other. So you dictate and define what you want to receive from the database. There's one more thing. Think about, I'm calling DOB to date of birth in the database, but in my logic, I want to call it proper date of birth. How do we do it? So in model class, there are properties in model class. So let's say name. On top of it, in Angular bracket, you can define what you want it to be. So there are so much features available in the model classes or Pojo or Poco that what all you can do. You can even define how much length you need. Now, since he asked that, why don't we communicate with database with model? When you are storing information, that is also going through this only. When you're writing to the database, then you populate these properties and you say, okay, for name, this is the required length. Why do we do it there? Think about it. Let's say my database has only 50 character length for my address, only 50 characters. And then what you did, you typed 51 characters. Now, when will it fail? If there is no model class doing that validation, it will fail when it will reach the database. And database will revert it back all the way. No, my column length is 50, you gave me 51, fail all the way back. When we do this MVC pattern, and in model class, I say required length. That's right, there you go.
This is a feature from the framework.
It is the feature from the language frameworks by out of the box. So when you give these property annotations, we call them annotation. I give an annotation like that. Now what happens automatically? That is validated before it hits the server. Means when it comes here, it says, oh, my required length is 50 only, you gave me 51, go back to the client. And then we receive error back and we show those red color exclamation marks and all good stuff. You understand what I'm saying?
Yeah.
Maybe next time I can come and give a talk on some coding and all that stuff.
I want to how flexibility of it. Like I want to put a regular expression to check.
You can.
Okay.
All those things are already there by the way. But he asked a question, if you didn't get it all the way to the back of the room, is can we put regular expressions? So these days, these programming languages, whether it is paid or open source or whatever, they are becoming powerful and powerful only. Every day they are becoming powerful. So before you do anything, you hand roll, always search and see if that feature is available. When he asked about regular expression is generally handled at the UI level, not at the server side. But on server side also, it's possible if you want to do it. But I gave you something like it's a tip of the iceberg, which I'm trying to explain here. Maybe next session I can come and show you in the coding only coding, you know, all the way end to end. So thank you so much, Sam, for asking about SOA. I hope that makes sense. A little bit of scribbling on the board. And I'm willing to stay back if you guys need me. Okay, I'm not in rush. I will hang out. You can ask me questions or whatever, something you didn't get. So I hope you guys understand it, makes sense for you. Now, since we have Monolith, right? Monolith is again one big block of code, one single database, all the functionality is built together and we deploy it all together. Now, since we had it so long and still we have it by the way, do not think that microservice is coming, it's on hype, it's a new buzzword, then there is no value in Monolith. There are still monoliths available. Then what is the value? What are the advantages of having Monolith? Everything has its own pros and cons. Same is applicable to microservices as well. There are always trade-offs of picking one architecture style over the another. Now let's talk about a couple of, the benefits of monolith architecture. The first one is a fewer cross-cutting concerns. Is there anybody who knows what a cross-cutting concern is?
Oh, it's right.
So cross-cutting, okay? So cross-cutting concern is, let me draw it on the board for you guys, okay? So what happens when we do things like that? Look at the diagram again. Everybody is looking at that? All right. Do not worry about the text from there. My presentation is not text heavy. I'm not reading the text. Okay. So look at the diagram only. All right. So in my diagram, the architecture goes like this. I have a UI. UI is your code which will run open in the browser. Make sense? Everybody is okay so far? In order to support that functionality, billing, customer, address, payment, and whatnot, you need some sort of code, right? That code is what? That code is living, let's say, somewhere here. It could be, let's say, Java or C#, whatever. And what it will have? It will have all the controllers in it. Make sense? Right? It will have controllers. Controller is nothing more than a class. Just like a code, and that code is living in those classes. And then you have your database. You have your database, right? We call it 3-tier architecture. 3-tier means there are 3 layers. The difference between layer and tier is, layer is the logical separation. So what I did, I logically separated 3 things together. Logically means UI is a separate code. Server side is a separate code. Model will live here, by the way. So it will have 2 things. Model is a term for POJO and POCOs, okay? So it depends on what programming language you have, but think about model. Now it has controller and model. This is another logical separation of code. And then I have my database. So what will you do? You will have your scripts, your table, create table, table name, right? Update table, table name, create trigger, trigger name. All those things you will have in a separate folder somewhere. So that is what my layered separation is. When we talk about tiers, and I said it's a 3-tier architecture, not crying tier, T-I-E-R. For many companies go with N-tier architecture. N means N number, more than 3. Okay, and I will tell you when that is possible. So when you do this with 3-tier architecture, that means you have a separate deployment for UI, means separate physical machine running UI only. There is a separate machine which is running only the server side code, and there is a separate machine which is running the database. And all these 3 things talk to each other with endpoints, referring to the connection string to database. Go to that IP address or endpoint and look for this table, get the data out and all that stuff, right? So when we do this, this is called the 3-tier architecture. Now, when I said cross-cutting concern, what does that mean? Now let's talk about it. Cross-cutting means if these are my layers, these are my layers, okay? And when you look at this, try to visualize when you go in this code, in your code, you will end up having something like this. If you will see it in any IDE, anybody use IntelliJ, Visual Studio Code, Visual Studio?
Yes.
All right, cool. So when you load your project, on this side here, you will see something like this. Controllers. And inside that, you will see customer controller. There will be proper name like that. .java. If it is C#, it will be .cs. All right. Then address. And again, controller is a word which is required by the convention of programming language. If you do not put controller word, it won't work. MVC pattern will not find it. So controller keyword is needed in the name of the file. Again, .java, .cs. So there will be so many. Similarly, there will be models folder. And to do all that stuff, as he was asking about relational, connecting with the database, you need all those properties here, files. So you will have customer.java, address.java, like that. So think about, visualize it, that how big even that layer going to be. Now when we talk about cross-cutting concern, there are 3 terms in it. Cross-cutting concern. I hope everybody understand what cross-cut is. If I'm doing this is cross-cut. Make sense? Isn't it? So that's what cross-cut is. But what is a concern actually? In programming terminology, in architecture word, not programming, in software architecture, concern means few things. Security is a concern. Logging, you know what logging is? Not login, not giving your username password. Logging. Logging means what happened at each step. Right? Performance, threats, monitoring. All these things are considered as concern. So if you read the text, I'm saying here are large number of cross-cutting concerns such as logging, rate limiting, security, DOS. DOS, anybody know full form of DOS? Denial of service, yes. So that is what denial of service is. Means you can hit the server so much, the server will go down. That's what attackers do, right? Now think about it. When you are doing all that stuff here, you need to write code for logging. How will you do it? Let's say I want, whenever something happens, it will log the information in some NoSQL database somewhere, or maybe in a relational database. It could be a text file, plain text file. I have done that in olden days. So it will just take the date time stamp from the server and write your username, whoever is logged in, and then say you access this database, or you did this table, something, some activity logging, nothing else. Now think about it, it is happening every time. Many websites, if you have been to, like bank websites and many other websites I have, accessed and I have, it tells you when you last logged in. When was your last login? How long have you been active in which session? What did you do last time? Like banking websites, have you changed your password on this day? All these things. So how do they record these events which are taking place? Changing password, ordering something, because they are writing it somewhere. It could be any logging activity. So rather than me explaining you so much about logging, let me talk about cross-cutting now. So when you are doing logging for these many controllers, and it will evolve tomorrow, you are shipping in US now, tomorrow you will ship in India. Then you need different system to receive payment. Right? Many times credit card doesn't work across the country, they will block the payment. You try making a payment sitting in US to France. The 99% chances are your credit card will not go through. If this is first time you are making an international transaction from the same credit card, they will block it. So in that case, think this way. I am writing logging functionality for customer control. Where should I write it? If I write that block of code, only in customer controller, would that be good? If I write that code here in customer controller only, would that be good? It will be good enough only for one time. What if address controller needs it now? It will change address. You want to log the information. When did you change your address last time? You want to ship something. You want to make a record, make an entry in your log that customer ordered something and it's being shipped. What will you do now? You copy the code, paste it in the different controller. Make sense? Yeah. That's an easy thing. Yeah. Copy paste, right? There is nothing wrong in copy paste. The only thing is you need to be smart. All right. So what we do now, since this is a concern which is coming across every controller, that was controller 1, this is controller 2, controller 3, controller 4, controller 5, 6, and so on. Now I cannot copy paste it. So what I do, I'm going to do this. Since I cross-cut, I'm going to write one file, one class, and that will be my logger class. In that logger class, I will write the function which does bare minimum thing for me now. Whatever I want. Whatever we started with, our requirement, I'm going to log it. Then, in every controller, I'm just going to say import. Everybody know about import? C# called it using, Java calls it import. Or think about you add a reference to it. You are referring to the dependency, where to get the functionality from. Now tomorrow you can say, okay, when I was logging, I did only date and time and from what machine IP did you perform that action. Tomorrow we want the customer name also, or the username who was the logged in customer. Can I do it? Yes, you can. So what you do, you come here and then start logging. So you change at one place. So this is a concern and it cross cuts across the layer. Are we good with this? That's what exactly cross-cutting concern is. Think about security. Security is a cross-cutting concern. You cannot write security only for one. What's security mean? Only an authenticated customer can access it. How would you authenticate? There are different ways of doing it. And then what will you do? You will do security here. When we draw diagrams in companies, our diagrams look like that, only what I'm drawing here. That's how we show what the cross-cutting concerns are going to be. If any one of you, after the class, you go and search cross-cutting concern, you may come across diagrams like that when you will search it. Are we good with this term, cross-cutting concerns? All right, very good. Let's move forward. A less operational overhead. What does operational mean? Operational means you build something and you launched it and then you want to make it functional, right? If a website is down, what will you do? No customer will access it, no money, no income, right? So you need to make it operational. With Monolith, it is very less overhead to make it operational. Why? Because everything is on one server only, right? Many times I have seen in the olden days that your UI, your controller code in a database, everything is on one machine only. On one machine. And as long as that server is up, you have enough RAM, enough hard disk space and all that, you are good to go. So less operational overhead because everything is together. Think about it, you all guys are here in one room. Is it easy for us to manage you when you are in one room or everybody is in a separate room, then we manage you? One room, make sense? Exact same thing. Performance. So performance, because everything is together, all the code is living in the same memory space on the same machine, means it's not making any hops. Even if it is making hops, that is just from one server to other server. Only 3 layers, remember this thing? One hop to this server makes hop here. Data comes from here to here, here to there. Easy, everything is together. And with this cloud and all, you can deploy everything in one region, east or west, whatever you choose, and then it will be even faster, right? So performance is faster because things are together, they are gelling together, they are near to each other. In Monolith, performance of your functionality, your code, how code runs, is faster in Monolith. Now, what are the disadvantages? Tightly coupled. Tightly coupled means everything is living together. All the functionality is living together. They are close to each other. And in that case, it is harder to separate the things. If you want to separate it for whatever reason, it is harder. We will learn about why we want to separate. It's harder to understand because there are so much code you are building. Many times what happens in industry is that there are not so many developers who are working on the code. And let's say new developer joins. Now that person needs to understand what code goes where, which class belongs to what database table does what, because the database is so big and only one person knows everything, who has been with the project from day one. And after that devs come, you ask somebody, the new guy, he will say, oh, I don't know, I have not been here enough. That guy knows. Or he will know only what he did, nothing more than that.
If the person that, what will happen to the company?
Company will continue, even no matter what happens, company will continue to survive, and that's how industry is supposed to be. Nothing changes if somebody leaves. Chances are that a person will come, that's what I believe in. And change is the only thing which is constant, you know that, right? So company will find better person. The only drawback would be they have to spend more time, pay maybe more money to get someone who will understand that whole thing and then make it functional again. I hope it will be working when person leaves, but making functional again means adding more stuff to it so nothing breaks. The job of developer is also one more thing. When you are adding new stuff, you don't break, right? Do you know if people online, is there anybody online there, or it's only you? Only you? Okay, very good. So,
I'll check with your code.
are we good if we go a little overtime?
Yeah.
I went whiteboarding and all. If anybody has to leave,
He says okay, okay.
if anybody needs to leave, please feel free. I know this talk was okay, but I do not want to be pushy that you have to be here. Unless or until you find it interesting, then it doesn't make sense. The reason is I went beyond my slide. Okay, so this slide is I gave to professionals, but to explain you, I did a little bit whiteboarding and all, so which is fine with me. But I want to be cognizant of your time schedule as well. All right. So, and I'm wrapping it up a little bit here and there where I can pick the speed. So harder to understand, I hope you understand that. It was easy. Deploy all or not. That's the most important thing. I love this statement. That's the key. If you want to take something out from Monolith, remember two things. What is Monolith? Monolith is one big bulky code where all the functionality is together. That's the easy to remember thing. And it's deploy all or not. What does that statement mean? I have done it many times by the way. I have written all sort of architecture, all sort of API, most of the programming languages. So what happened in that case is, think about it. You have customer controller, address controller. If we need break, let me know. I can give you a 5-minute break. You can go grab coffee or whatever. I'm here, okay? But I want to make sure when I leave, you understand it so well that you can explain it to someone else. So let's say I have customer controller.java, address controller, shipping controller, billing controller, payment controller, and many more. Since everything is together, I intentionally kept that diagram over and over repeatedly on every slide, so it sticks in your mind and it comes in the night in your dreams. So never forget it. I solve problems in dreams. Last night I solved one problem for one of my friends. I called him this morning, he didn't pick it. I will call him again when driving back to Redmond, and I will explain him how to solve this problem. He had some security concerns. So that came to my mind last night when I was sleeping, and I know the answer to that now. So what happens here, remember that diagram, this one big code, you are deploying to one place, call it as your AWS, virtual machine, Docker container, or any server, you are deploying that code together. Now, somebody came and said, you know what, now we started shipping to Mexico also. Can you add that functionality in the code? Now think about it. Where these changes are required, do you know? In how many places that change is required? All 3 places. First, UI needs to show a drop down, not only United States of America, but also Mexico now. Make sense? When you are putting the address, you need to validate the address. Is it the right zip code? Make sense? There is address validation happening. Then you will come to address controller. Country could be only Mexico and United States of America. Why did I say that? Isn't it already selected by the UI? Not always. When your tester will test, quality assurance, testers, they test the code, they will test UI separately and API separately. To test the API only, there is a tool called Postman. There are tools where you can hit the API endpoint when you are developing localhost or the real endpoint on QA and dev environments, and they can test only API code. They will behave their UI. What if I inject India at that time? What will you do? If your address controller doesn't know what 2 countries I'm supposed to choose, then how will address controller behave? So address controller needs the validation. In database, if you have a list of countries in a table somewhere where UI is pulling it out, then you need that functionality there, right? You need to put 2 countries in the country table, and your UI is pulling that from the database. When UI loads and you go drop down, you click, it makes a call to the database, bring 2 countries back, sort it alphabetically, and show Mexico and USA. Are you following along? Maybe it's too much, but I hope visually you are able to follow along, okay? That's how we do it in industry. Now, you did that change, all good? So UI change, all good. Address controller change, all good. Now what is going to happen? Since everything is living together and I made a change only in one, let's say address controller, what I'm going to do? I'm going to build the entire code again. You compile it again. Compilation errors are the most scary errors. One error will trigger hundreds of errors, right? So you compile everything and then you redeploy everything. You are redeploying everything. That's what we call deploy all or none. I have done it hundreds of times. Even though we did it on Azure, which was click, 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 but we built that infrastructure that how Click will take the code, build it, deploy it, run it, test it. We did work behind it. It was Click, but still everything went up. What is the drawback? What's wrong in it? I mean, deploy everything, how does it map?
Slow.
All the services can be down.
So it is, he brought a term called slow. It is slow only when you are doing that. It's building, compiling. By mistake, you put a colon here, semicolon there, removed a space, something happened, and then you fix those errors and then deploy it, right? The issue with that is, with companies, big companies, whenever you deploy any new code, you need to tell them what are you deploying, and then they will test it. With any big company, you cannot just deploy and say, okay, I deployed, I'm done. No, they have to run regression tests. Means nothing is broken. Now, since I deployed, how would you ensure nothing is broken? Think about your areas of functionality you have. How many regression tests could be there? Just to number few thousand. So before they go live and open the traffic for production, the real live customers, it will take them almost a week or two to test all these things and certify that nothing is broken, everything works fine, launch the code for Mexico. I'm telling you the industrial concern. But with the small applications and all, you are fine. When I was doing it for a small company who had a lot of money, it was fine. Because, yes, sir, go ahead, please. I'm sorry, I can't hear you. Downtime also. Downtime? Yes, so it depends. As I was giving you the example of getting the test certification, unless that is done, you are down only. But and that's why I said with small companies it's fine. But with real enterprises, it will be down for some time. Either they block that functionality only, that you cannot ship until they finish testing behind the scenes. But no company can take the entire website down for those many hours. So they have to fast track or whatever. But yes, that's another thing. Now another one is scale, all or none. Who knows this term called scale? What is that?
There is want more power. Yeah, you want more traffic. So
Can you speak a little louder for everybody's benefit, please?
so but you have to scale. Which means you want more traffic come to your application. So you have to scale.
So scale has a term called scalability. Scalability is another architecture term. Scalability means when traffic increases or load increases, perform doesn't decrease. T-Mobile did iPhone 10 launch. People go crazy. I do not use iPhone. I use Android. All right. So I'm an Android person. I don't use Apple products. Now, what happened with that is every website went down. We had 600,000 concurrent users hitting T-Mobile website when we did the launch last year. We were the only one who didn't go down. We were so much ready for that. So scalability means when load increases, performance doesn't decrease. If you have a Mustang which goes 0 to 60 in 4 seconds, there is 1% me or 6%, it still goes the same. That's what scalability is. You understand what I mean? You get it? Now, there are two types of scalability. Scale up, scale out. What is it? Can you repeat it for me? Scale up, scale out. Let's say I have one VM. VM means virtual machine, just a server. Just a server, okay? You have one server. One server having code in it. All good? That thingy, repeated screen in front of you so it comes in your dreams tonight. Now that code is all deployed here. It's working just fine, beautifully working fine, no issues at all. One user came, 2, 10, 300, 200, 400, everything is working smoothly. Database is responding, everything is going fine. 100,000 came. What will happen? It will go slow by slow, and then it will die. So how do we do it? In olden days, it was so hard to predict the traffic. People were requesting new servers. Get me a new server. That will come in 2 weeks. Then I will put it under my desk and I will sleep on it. And it will have 64 GB RAM. The first laptop I bought back in 1993 or 1994, it has 4 GB RAM in it. 4 GB. Sorry, 8 MB. And the hard disk was 630 megabytes. 630 megabytes was the hard disk. So now what happened with this server? I'm giving the current example. We are talking in GBs, not MBs anymore. Okay? Because electronics is getting cheaper, memory and devices are getting cheaper year after year. So we have this thing. Now, there are two things you need to remember. Scale out, scale up. Only two terms which exist in industry among architects. Scale up, scale out. We are solving the problem of scalability. Scalability means when load increases, performance doesn't decrease, or your service will not stop functioning. Now, what happened with this? Scale out is very easy. It's nothing more than redundancy, duplicate it. You had one server, good, add one more. Same thing, let's say 32 gigabytes, 32 GB memory, whatever infrastructure, Pentium processor 5, 6, whatever you have, 6 core, 8 core, whatever. Just make better, add one more. If I add one more, how would UI know where to go? You have the same code here, deployed twice. How would UI know? This is my UI.
Load balancer.
Load balancer. Load balancer is another hardware component. And what it does, the moment request comes to the server, it says, oh, there is a round robin algorithm. First customer, go here. Second customer, go there. Just like that. Right? There are different algorithms available as well. There are many more algorithms available with these load balancers. Nginx, have you heard that term, Nginx? They make load balancer. F5 network, F5 red color, they make load balancers. All right? Now, this is what? This is scale out. Make sense?
Yes.
Scale up. Who can tell me what scale up is? Scale up is not putting one server on top of another server. Scale up means adding more hardware to it. Let's say I have only 2 cores, and there are now these days that you can take the hard disk out of the rack, inject processors and things like that in all these data centers today. You add more microprocessor. You insert more RAM chips into it. So it was 32. When instead of having 2 servers, I have only one, but it has slots in it. And I fill hard disk into it, RAM into it, microprocessor into it. So I increase power of that server only. Make sense? Are we good with this whole thing? Yeah. So with this thing, Monolith, when I am doing this, no matter what I do, I am scaling everything. Now let's go back to the Apple phone launch. Yeah. So after this, so what happened with that is when we did Apple phone launch, think about it, when we were doing, any company does Apple phone launch. What are the 3 systems which will be needed out of this? Out of these 6, which 3 boxes will be touched when there is a new phone launch? Payment is the first one. For sure. What else? Shipping. 2. What is third one? Billing. Order.
All of them.
Inventory. Customer is not that important because I could be a new customer. I don't exist in your system. You understand what I mean? In that way, I'm talking. So billing is also not important because you are not doing EMI, you are buying a brand new. So in that terminology, billing is when I am on the EIP, equipment installment plan. You walk to a T-Mobile retail store or any store. You say, okay, I need this device, run my credit check and all that stuff. When we do the iPhone launch, we say, okay, give me $1,100, we give you the phone right now. Or we did the pre-ordering thing. Remember those days? Yeah. I do not go through that saga because I use Android, but so whoever has gone through it. So 3 things were important for me. If I see, inventory check was the maximum calls we made. Inventory check. Do we have enough phones? Everybody wants gold color only. How many gold phones do I have? Make sense? You want 32 gig, you want 64 gig. How many 32 gigs I have? And it's not like you want one and I have inventory only one. If we want to sell you one, we have our own standards. We will have at least 25 phones there. Then we will sell you one. That's how it works. It's not only one is there. Let me sell that one to you. Because why? Concurrent orders come. If I ensure one for everyone, what will I do to the next one? Right? So we do not want that confusion. So that thing happened. So at that time, we had to scale inventory calls. Calls are going crazy to inventory. Everybody wants that phone. Before we reserve it, you load in your card. Before we load in your card, you add it. We have to make a check call to inventory to check it. It confirms I have it. Go ahead. Add to the card. Payment. Payment was hit like crazy. People paid by PayPal, credit card, MasterCard, debit card, Amex, whatever, right? Whatever medium is there, which we accept. And then shipping. It could be pick up in a store. Mostly it was shipping. They will ship it to you. Right? Now in that case, there was nobody who came and who said, okay, do you know what? Can you change my address, please? That is a customer thing. I want to change my plan and service. I'm on T-Mobile One. Add international calling to my plan or whatever. Very less calls, like maybe 1 out of 1,000, like that. That night. So what we did, we only scaled those components. We scale up, we scale out. Only those components which were supposed to hit that traffic. And how do we do it? Are you sitting in the server room? No, it's all auto scaling. Auto scaling means automatically scale. How does it do it? It has sensors in it. It knows, you know what, traffic is coming. Let me add more RAM to it. Let me spin another instance of the same service. So it is scale out, scale out, scale out. And if needed, scale up, and then it goes up as well. Yes, sir, you had a question.
Yeah, when you say scale up or scale
out,
you mean like just for the sake of this promotion, you have to buy new hardware?
No, we don't buy hardware. We are on the cloud.
So you just ask for more.
So we don't ask anybody as well. On any cloud team, there is nobody. If you call Amazon, that add more server, they won't do it. There is nobody. It's all in your panel. You have your own portal, customer portal, where you manage your resources. And you go there, you set the rules. And from tonight, Apple phone launch starts at 12 a.m. August 9th, 2019. We say, okay, on 12 a.m., spend 10 more instances of these things. And each instance should have 5 GB RAM in it. And on August 10th, I shut it off. I bring it back to 1 or 2, 3, whatever the regular business mode is. So what we did, we paid money only for those number of days or those hours. And that's what cloud is, pay as you go. To answer your question, we did not call anybody. We did not buy any physical server. It was all on the cloud.
So when you say on the cloud, that wasn't, I don't know, 2004, 2003, something like that.
Okay, in those days, okay. I gave you the example in current. So in this case, yes. If it is olden days, you have to either inject something in the server ahead of time, or you have to buy a new server ahead of time.
So for this example,
No.
especially T-Mobile, I don't think they use AWS.
We are AWS only.
No. Okay, so you let's say you don't use any other provider.
Cloud provider?
Yes, you don't use it. So you have to buy your own.
In that case, yes. If you are managing your own infrastructure, your own servers, then you have to make sure you buy it ahead of time. But by the time server will come, Apple phone will be all sold, and you will make no money. Yes, sir. Go ahead. You are the only one.
So I think right now, if we use some serverless service like Lambda, we can scale out individually for different functions.
So serverless is not just a storage thing. It has a functionality in it. So it executes a function and then it just go back to sleep. That's what it is.
But we can scale out individually.
Everything can happen, yes. But that's a different topic altogether. So I don't want to get into it after this session. I'm happy to talk about that issue. I hope we are good with this, right? Microservice. We take a break now. Keep going? Yes.
You were talking about deploying all that one.
Yes.
So, I mean, if you change a part of code and then deploying all of that, which is actually impacting the slower line, we don't have something like the loggers which you showed us there, where it is directly attached to whichever item tells us that function.
So if you recall, logger was the cross-cutting concern. Even that is being redeployed. Everything will be redeployed because logger is nothing. If you remember my diagram I drew here, it was like all these controller has their own classes. I made a change only in address to add Mexico to the new shipping country. Made some change in UI, made change here, made change in database and all that stuff. But logger still stays there. I didn't make any change there. It was as is. If you think in any other controller then but address, I did not make any change. They were untouched. Theoretically. Unless somebody go remove something, add something, then of course you made change over there. But many times when professional developers work, they are very cognizant of what they are changing because they know the more I change, the more impact you can cause. You need to be very careful not to do fat fingering in your code and inject things here and there and break it. Did I answer your question? Are you good with this? See me after this if you, or in the break time if you want anything. I don't want you guys to go with any confusion. Okay? Microservice, as the name is micro, means it is small. Make sense? How many of you know why name is Microsoft?
Microsoft?
Yeah. Why? See me after session is over. Not in the break after that. Do you know why name is Java? No, you need to know all these things. I will tell you. I will tell you why name is Java. So this is the definition from Gartner. Okay. So this is the industrial definition. It's small autonomous. So what does small autonomous mean? Small means take each responsibility out in a separate code altogether and then deploy only that one. So it is tightly scoped. If it is customer, customer is together. If it is billing, billing is only together. Tightly scoped, loosely coupled. Earlier in Monolith, all code is entangling together. They are living together in the same memory space. With microservices, everything is loosely coupled. Single responsibility means each code knows only its own thing, nothing else. And that's what microservices. And because everything is so small, so contained by itself, self-controlled, that's what autonomous means. It's self-governing, self-controlling, self-healing, independent. That's what autonomous means, right? It is independently scalable. It is independently deployable. Think about it now. Let's say we break apart Monolith and we took address controller out into a separate container or a separate machine or separate server. Now, when time comes to deploy that change, remember I said you are deploying all or none. In that case, you would have ended up deploying only that code. It will take you milliseconds to deploy. Boom, like that. You click, code goes on the server, go to UI, hit your URL, Mexico comes in. With Monolith, it will take time. Building your code on the server, building. Now you're pushing the code. Code is loading, deploying. Then you go to the UI. Okay, something is wrong. What did I change? Only that. It's not related to this. Let's go find something. You get in the rabbit hole of finding issues. So the idea is, when there are so much stuff, you need to be very, very careful what you are touching, because you don't know what you can break. Now, this is what microservice architecture looks like. This is the diagram I drew on draw.io. Once I'm gone, on my LinkedIn, I have published these articles. They are also on my blog. All right. You can always go and refer back. Most of the stuff will be there. And few things I'm telling you in the talk, nothing can be written all the time. But so with this, what will happen is your UI is UI. It's one common place where you see all that stuff. But what we did, we broke the services layer. Remember Monolith? Look at this thing here. One project, everything is together. In this case, all projects are separate. And what you are doing, remember there we were having one big box where all these things were together. And there was only one arrow going to that box and talking to the functionality. Here, there are multiple arrows coming from the UI. Multiple. And each thing is in its own self-contained area. So microservice is autonomous. They are independent. And everything is separate. With the beauty of being separate, they also do not have one big bulky database. Remember monolith diagram? It should be imprinted in your mind now when I talk about that. Big database. Here, so many databases. Multiple databases. Now you might be thinking, is it not that database is so small? Yes, it is. That's the beauty. You are breaking big into small. Small. Slice and dice. Slice and dice. Make it apart. How do I make it apart? That's the thing. How do I decide what make to apart? Where does it go? We are going to talk about it. Now, this is the interesting part. Microservice is still a buzzword. Not many people know about it. Not many people know how to implement it. Not many people know what it can do for us and whether I am ready to go and do it or not. There is still a lot to happen. By 2023, this is supposed to go up by $33 billion industry. I need just 10% of that. So, you need 1%, all right. If I get 10, I give you 1. So you pray for me, I get it. So there is always money involved behind industry, right? IT industry. There is always money involved in cloud, Azure, AWS, whatever we do, right? There's always future associated with it. As I started the conversation when I came, that we don't know what you will become tomorrow, right? You could be a UI dev, you could be a designer, you could be a data scientist, whatever. But whatever you do, always remember these aspects, because that's where the things are happening. If you build a weather app, new weather app, you build your own, Uber type company, which will do something. Everything is happening through the API calls only. You see those scooters and green bicycle today? You go by the phone, scan it, take it, drop it wherever you want, pick it and all. Everything is making calls from your phone app. Right? So everything is behind either SOA or microservice. With latest and greatest, microservice. The older one like weather.com and all, SOA. But now they are also changing to microservice. Netflix, microservice. Are we good with this thing? This one? Yes, sir. Go ahead. Yeah, that could be by mistake. Actually, everything is supposed to be bidirectional. Everything, but it just shown like that only. But everything is bidirectional. It goes up and down.
Also, another question. Each microservice also using Monolith architecture.
Yes, that's right. Everything will have its own controller. Exact same thing. I will talk about how to migrate from Monolith to SOA. Little bit. I will cover that part. I will tell you how to do it. That's why I left this thing on the board intentionally. Now this is, look at it, what it is. So this is like a Amazon website. It may not look like this today, but it's almost equivalent. Then I will give you one example of Netflix with the same thing. Now think about it. This is my UI. You see that composite UI? This is my UI here on the board. See it? UI here. With Monolith, we had one big thing. With microservice, what Amazon and Netflix and T-Mobile and all these companies are using, you have multiple things. You see that? You see all these things? These all are microservices. All right. Now, with UI, you see these red boundaries here. Each red boundary indicates that I am talking to one microservice. Do you see these boundaries here? Do you see all that stuff? Means each section is talking to one particular thing. I will give you one very nice example, which is given in many talks, and many books also talk about it. Netflix. Think about Netflix is your UI. When you go to Netflix, you log in, you choose your profile. I choose my profile, Vidya. I go in. What does it show you? Recently watched, trending, movies and adventure. Continue watching. Are you with me?
Yeah.
You get it, right? Yeah. I may have said few things wrong, but this is what the main sections are. Make sense? Think about it. It was Monolith. Then what would have been happening? 2, 3, 4, 5 call goes together, bring data back, render in the UI. Everybody is with me? But everything is working either together or failing together. Make sense? Many times with UI, what happens? When so many calls go out, we want to make sure that every call fetched me the data, then only I show on the UI. Otherwise, I say, oh, what did you fail? Why it failed? Let me try again and whatnot. So in such cases, many times your UI will not show anything at all, or you will keep retrying, and that is a spinner of death. Thinking, 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 and then you log out from Netflix, go to Amazon Video, right? With Netflix, what they do you know that? Every slider is different microservice altogether. Means trending now is a separate microservice in Netflix. Continue watching is a separate microservice in Netflix. Movies and adventure is a separate microservice. TV shows is a separate one. Documentaries is a separate one. And many times, if one is failing, let's say trending now, fail, you won't even know. The UI will adjust the space automatically, and you won't even know that trending now is not coming. And after some time, it will come again when service responds. You understand what I'm saying? That's the beauty here. So many times you might know, you might not observe this header is a static thing all the time. This is static. It's not going down anytime soon. But when you go to this accounts or orders, that may go down. When you click, then it make a call to like microservice. But what if this thing goes down? You won't even notice. Who cares? That's anyway down. Or if one thing from here is gone down, you won't even notice. So they have, if this service doesn't respond, what do? I consume the space. You do slider right, chevron, there is a chevron. You keep going right, then it rotates. Remember on Netflix, if you keep going right, that will come back, right? So it rotates. So they will expand the width and things like that. And that's what microservice is. Are you with me so far on this? So you might, when you will absorb it, and I want you to argue with yourself and ask questions to yourself and understand, then you will realize what the differences are. And there are very few people in industry who really understand what is the difference between two and why and which one. Many people just move from one to another without knowing what it is. But that's not what my style is. I believe in what and why more than how. What we do today is with copy-paste programming, go to internet, how to write microservice in Java. Some blog will come, copy the code, paste the code, make it work, go home and see. But if tomorrow somebody asks you, why did you write it? Oh, I don't know. Do you know what is microservice? I don't know. So I believe in more in what and why and not how. If you figured out what and why, how is easy. You understand what I mean? Yeah. So I go behind those things. That's why my talks usually cover a lot of insight into these things, not just showing you. But if you want to invite me again, I can come and show you how as well. Now, advantages. I will go very quickly with this because everything is kind of opposite. What was the disadvantage in earlier is the advantage here, and then vice versa. Scalability is easy. Why? You only scale what you need. It's not scale all or none. It's only scale what you need. Make sense? Everybody with me? Easier deployment. Why easier? You are only deploying whatever you want. If I made a change in address, I only deploy address. That's it. Nothing else. Problem isolation. Remember I was saying, if you fat finger something, build error comes, you are so scared, what did I break? I only added one country, but you have to see everything. Sometimes you get in the debugging mode. You put the breakpoints here and there, traverse through and tab flow and all that, right? So problem isolation, because it's only that single thing. Single responsibility. Single responsibility, at that time, what is responsibility? Let me talk about it. So responsibility means the requirement, the reason for change. In architecture design principles, single responsibility is a design principle, which means what is the reason for change. So reason for change at that time was address. You got a requirement regarding address. You changed something and then things broke. With microservice, everything by itself is a single responsibility. Look at this where I am rotating it. Customer, it has its own single responsibility. Earlier, everything was together. Means all responsibilities were together. Right? Separation of concern. Remember the concern we talked about? Your logging code was also living there only. Security code is living there. Everything was together. But now you even separate the concerns. And then deep domain knowledge. That's something which I want to talk about. What is domain? Domain is the knowledge area. Like T-Mobile, I am working now in the telecom domain. If I go and join a bank, I will work in the finance domain. If I go and join a healthcare company, I will work in the healthcare domain. If I go and join Amazon, it's a retail domain. Make sense? That's how, if I join a university and start developing code for them, it's education domain. Think about like what industry you belong. That's what domain is. When we say domain knowledge in terms of software is, customer is a domain by itself. In T-Mobile, in Amazon, in Netflix, everywhere there are so much, one dedicated team for customer only. In T-Mobile, we have dedicated team which only looks at the customer information. That's it. Name, first name, last name, social security, credit score, this, that. All the information about customer, your account, they have. So it's a domain by itself. Means when you work in a microservice setting, you really become specialized only on one thing. That's how we do in T-Mobile. Amazon does the same, I believe. So if I need to change something related to customer, it's not that one dev can go and change it. They need to set up a call with the customer domain architect, ask them, where are you storing that information? Do you have that information? I need this. By when can you do it? So they will tell you when they will do it, whether they will do it or not, or where they will fetch it from. So there are dedicated domains. Same, we have payment domain team. Their job is to be the interface between T-Mobile customers and the payment acquirers. Payment acquirer could be Visa. There are so many companies which process payment for you. So we have our own team which will interact with all our applications within T-Mobile. We have so many applications for prepaid, postpaid, and many others which you see in retail, care. And then those applications will talk to the same payment domain API, one microservice. All will talk to that, and that service go out to multiple payment acquirers and then collect the payment. So that team now has deep domain knowledge about payment only. So any question come to payment, all the team go to them. They are the architects for that. But if you ask them, do you know about customer? They know a little bit, but not that deep. But what their depth is in the payment domain. Is it possible that one person can have deep knowledge in multiple domains? Yes. But that will be possible only after having experience from moving from one team to other team.
By the way, let's wrap up and have some Q&A.
So let me go a little bit here. Disadvantages, cultural change. So it's not easy that you can do microservices just overnight. Your team needs to have some sort of understanding and your eagerness to change into that direction. Then only you can do it. And then it's more expensive. It's more expensive because you are breaking things apart. What you were deploying earlier on one server, now you are having multiple servers. What you were monitoring at one place, you are monitoring and controlling in multiple places, right? So that's why it becomes more expensive. Complexity. It is more complex because you need to establish communication between the services. How will one service talk to other service? Everything is deployed on a separate machine, right? So then that communication dance is the key. Many web service, many microservices today are running on HTTP, it's the REST call. It's on cloud and all that stuff. So there are endpoints exposed from one service to other service. And then you make network calls. Less productivity. Because if I need to change the customer address and then I change it in my customer microservice, but then orders team also need to know that Mexico is a valid country, and then payment also need to know that I can accept credit card from a customer who is in Mexico, and then shipping also needs to know we are supposed to ship to Mexico. Means you were supposed to make change in one place, but now think about it, how many teams are involved. So at T-Mobile, when we do any such thing, at any given time, minimum 5 or 10 different domain architects are talking to each other. And then we decide who will do what and how, and we create architecture diagrams, and we give information about their code to each other. Good, we wrap up. So I had some real world. Let me give you one real world example. How we did it. That will be very helpful for all of you. Okay. And I'm going to write some articles on it, but you can step back and talk to me outside. Let me give a real world example of microservice. Okay, that's what we did at T-Mobile also. So with real world example, think about it this way. Everybody has some sort of phone connection. You are paying auto pay to somebody, maybe you are prepaid or whatever. Let's say you are auto pay, you are postpaid. You are supposed to be billed every month based on the cycle, 30-day cycle, 30-day cycle. You are billed every month, and automatically your payment is processed with a credit card. Make sense? Are we good so far? Now tell me one thing. In order to do the auto payment, do you know what we need? They need your credit card to be stored in the system. Yes or no? Anybody has received ever a notification or email or your payment failed because your credit card changed, expired, or a new number got issued to you? It happened with me just 2 days ago. My credit card was compromised, and then Citibank issued me a new card. T-Mobile, my employer itself, they could not process payment. So I received an email that we could not process your auto pay, update your credit card information. Are we good so far? We understand the landscape? Yeah. Within T-Mobile, what we did earlier, before microservice, we adopted 100% for one team. Billing team will give you the API out to the UI to store your credit card information. Billing team. So billing team will give you the API out, give me your credit card information. We will encrypt it, send it safely so nobody can hack it. Now they will store your credit card information, and when your time comes, they will send billing amount, billing date, credit card number, and how much to charge to the payment department. And payment will take that information and run it. Means execute it. What we did, billing is a separate domain altogether. Payment is a separate responsibility altogether. In order to strict to deep domain knowledge and single responsibility, we separated these two things. So billing no longer owns the credit card information or the payment information. Only payment team knows. So what we did, we decommissioned the API with the billing team where we were sending payment information, credit card information. Payment team spun new APIs to give us the endpoint, and we started sending credit card information, expiration, year of expiration, name on the card, all these things, zip code to payment team. Now payment team has it. So billing only knows how much to bill, when to bill, two things. And then they will send information to the payment team. Bill $89 on every 5th of the month to Vidya, Vrat, Agarwal. And that's it. And this is the customer ID. Now payment team receives that information. They already have your information in the system. They will find customer ID. Vidya, Vrat, Agarwal. Yes, this is the name what matches. $89. Credit card is already on the file. Run it. This is what microservice architecture is. And how do you do it? You need to go in your system, entire landscape you have. Think about what it is and start breaking it apart. If you look at your monolith, everything together, customer is a separate thing, put it in a separate service. Order is a separate thing, put in a separate thing. and wherever you have confusion, see where the inclination is, where it is gravitating towards, and then you separate it out. All right, so thank you so much for listening. I really appreciate it. I really want to make sure you understand and learn few things.
Yes, actually, we have a small token. So later, this one you can put into the 10% over that.
I'm sorry, what?
10% over the what is the gross? Put into the here, 1% to me back.
Oh, okay.
Yes.
Oh, thank you.
Thank you so
Yeah,
much.
yeah,
Okay. Thank you.
Thank you, sir. Thank you
Yeah.
so much, sir,
Thank you so
for
much.
having me. Appreciate it.
Yes. Now, Dr. Lam, you can control the question. Okay.
Quick question? Make it short.
So do we have to, in microservices, do we have to segment the databases?
Yes.
And does it help if we make it NoSQL database instead?
So nothing will help. What happens in this case is, do you understand his question?
Yeah.
His question is it mandatory to have separate databases per microservice? If you want true microservice architecture, answer is yes. Second thing he asked in his question is rather a statement that is it not beneficial if we keep it NoSQL? Now, since databases are already separate, there is no primary key foreign key relationship because they are anyways two separate things. So you can keep NoSQL if you want. They don't connect. So there will be duplication of data, and they all will make API calls to each other to find the information.
Duplication.
Okay. Also, I have two questions. Here, you are doing microservice means you assume infrastructure to cloud.
That's right.
Without cloud, you can.
You cannot.
Second, how can I need a full stack using the monolithic approach. That part I am a code. I want to teach this one in academia. What do I have to change to teach this?
You hire me.
Yes.
It's $1 million. So we have like 10 years.